Okay, Laura, this is the other one you asked about, number 7. So we're going to talk about, this is not related to a word problem. It's just straight up solve for x in a problem like this. And this is when the x is located up in your exponent. So there are some very specific steps that make this very easy. There are different ways to do it, but this is the steps I recommend. I could show you several ways, but I'm just going to show you the first way. The first thing is the same no matter whose expressions you're looking at. You want to get the base and the exponent by themselves. Isolate the base and the exponent. Isolate means move the numbers to the other side that are not part of the base and exponent. So we want to just deal with something that has a base only. So this has this extra 2 out in front of it. Here is the base and the exponent. That part right there, I want to have by itself on the left-hand side of this equation. So in order to do that, I'm going to get rid of the 2. Do not multiply the 2 times to 3, because order of operations doesn't say you times before you do an exponent. These parentheses especially emphasize that this isn't 3, it's 3 to the 3x, some other thing. So you can't take and multiply the 2 into that. So what you have to do instead is divide both sides by the 2. So that's going to give me 3 to the power 3x equals, and now I am going to get my calculator out. Where'd it go? And do that. 31,248 divided by 2. 31,248 divided by 2 is 15,624. 15,624. I do use my calculator to simplify expressions when I can write down an exact value that represents what I was dealing with. If this had been a square root or something, I would probably carry the square root through, because you don't want to use estimates in the middle of a bunch of calculations, because it makes your answer less and less accurate. Okay, so now we have the base and the exponent isolated. So now the next thing to do, we're kind of working our way towards that x and the exponent. So the next thing I want to do is eliminate my base. Now, this is the whole point of logarithms in terms of what we're going to use it for in our class is you could convert it to the other type of equation, convert it to a logarithmic equation, but I'm just going to go with inverse functions. And what I'm going to do is I'm going to apply a logarithm to both sides. Now, remember, logarithms have infinite numbers of different kinds of bases. So we want to apply the logarithm that has this matching base of 3, because that's what a logarithm is. It's an inverse function to a function that starts off with that same base number. So we're going to use the logarithm that has the matching base of the expression that you're looking at, the base number you're trying to get rid of. So you're going to use the matching base. So in this case, since it's base 3, we're going to apply a log base 3 of both sides. So here we go. So we're going to apply the log base 3. So when you do a logarithm, you write it in front of whatever it is that you're trying to take a log of. It's kind of like a square root. You write it in front of whatever it is you're trying to do, 15,624. Now, as the side with your variable gets simpler, as you eliminate things, it's going to show up over here and get a little more complicated looking, because I don't want to calculate that logarithm yet. But anyway, since this base matches this base, they cancel out. That's what logarithms do. They kill off bases. So now all I'm left with is what was the exponent. So now I've got 3x equals this logarithm, 15,624. And then you just have to basically look at the expression you have left, because now your variable isn't in the exponent anymore. It's just in some regular expression that should represent some kind of equation you have had to solve before. So I'm just going to say, finish solving the equation for the variable, because I can't be any more specific than that, because this particular expression might look different for everything else. If it says 3x, we're going to divide both sides by 3. If it says x minus 7, then we would add 7 to both sides. We just do whatever it takes here to get the x by itself. Now, since this one is 3 times x, to get x by itself, we just divide both sides by the 3. And this is my value for x. So x is, I'm going to kind of cheat and just write it right there. X is So finish solving your equation for the variable. And if it asks to round, then you want to round. In this case, let me look at the homework and see if it said to round it or if it wanted an exact answer. Let me look. Okay, I can look it up again. It says, do not round until the final answer and then round to the nearest whole number as needed. All right. So this is exact answer. This is just how to finish up. Use exact value with the logarithm in it, or round to whatever is specified. If it says use the exact answer, though, you want to put the logarithm in there. Get back to you. Sorry, let me show you what I just wrote down here. This is really, these are your 3 steps to getting it solved. But the third one kind of open-ended. But what to do with it, that kind of depends on what kind of question it was. If it says put in the exact answer, then you're going to put this whole thing right here in for your answer. Be careful to build it carefully. Close your parentheses around the input to the logarithm before you divide. But if it says round to whatever is specified, well, now I'm going to put this into my calculator, divide it by 3, and then see what I get for my rounded answer. So I'm going to have to continue this one down here. So this is to finish up my example. X is exactly log base 3, 15,624, all that divided by another 3. If I wanted to round it to the nearest whole number, now I'm just going to build that on my calculator. And this is where you better hope you have the log base. Is that light off? No, that light off. So it's a little bit easier to see my calculator. No? Here, let me just do this instead. I'm going to switch over to, let me share calculator. Okay, let me get back to the regular screen. Okay, so I'm just going to type that expression in. It was a log base 3. Hopefully you have one of the nicer calculators that has the base already programmed in for you. But the way to find that is you have to go to your math button. And I think it's faster if you scroll up, but if you scroll way on down there, you're looking for something that says log base. It's right there. Okay, so if you select that, it should give you, if you have that log base, you should have the option here to put in the base that you're working with, use your arrow buttons, and then put in your 15,624. 15,624. This already has the parentheses built in. I'm going to do it all in one step here. So I'm going to divide all that by 3. You can do it in one step and then divide your answer by 3, doesn't matter. And that is my estimate, 2.9299, so on, 2.929. Now it also said round it to the nearest whole number, I think. So that to the nearest whole number then would be about 3. So that would be your final answer. Let me unshare this. So I carried all my calculations through until I had the X by itself. I put this into my calculator and I wrote down several decimal places, but since it said round to the nearest whole number, I could just look at the 2.9 and know that rounds up to 3. So this rounded to the nearest whole number. The solution is 3. A bunch of 3s in this problem. If you had to round it to other values, you could use that. Your calculator goes on out however many decimal places you need to round it to whatever accuracy you need. All right, so to summarize, anytime you're trying to solve an equation where your variable is in an exponent, the first thing you want to do is eliminate anything else on that side of the equation that is not part of the base and the exponent. That's why we divided this 2 on both sides, to get rid of the 2 over here. So if you're going to divide this side by 2, basic rule for equations is do whatever you want to one side, as long as you do the same thing to the other side so that the results are still equal. So we're dividing this by 2 to cancel the 2, we're dividing this by 2, and we wrote down this number. Then once you have the base and the exponent isolated, this is where you apply a logarithm. So this is the new step from Module 3, Chapter 5. Apply a base 3 logarithm on both sides. That 3 has to match whatever base. So since your base 3 logarithm is being applied to a base 3 exponential expression, the base of 3 and the log base 3 notations cancel out. That's what logs do. They're inverses to exponential bases. Okay, that will produce just the exponent as the only expression on the left-hand side, which should be more comfortable to finish solving. But when you apply that base 3 to get rid of the 3 over here, make sure that you introduce the same base 3 log on the right-hand side. So whatever your base is, take that same base on both sides. So now you are building an answer over here that has a logarithmic expression in it. So that logarithm is going to be part of your final answer every time. Then you do whatever is left to get the x by itself. It's not in the exponent anymore, so you don't have to do anything fancy. Just eliminate whatever numbers are with it by doing the opposite, what that number is doing. So that's why we're dividing by 3. And that gives us, we cancel the x out, and that just gives us plain old x equals this, the log thing, divided by the 3. That is the exact answer. If it says, do not round your answers, put in the exact answer, this is what it wants, something with a logarithm. If it does say round to the nearest whatever, then you can go and put it into your calculator and then round that appropriately. Okay, so I hope that helps, and let me know what other questions you have. Bye.